Hello, today our group would love to present our project named COVID-19 TrendVisualizer. So let's start. Firstly, this project analyzes and visualizes COVID-19 case and vaccination data worldwide using Python. Users can select specific trends for individual countries and view results as line graphs and bar charts. Next is our project objectives. So the first one is to develop a tool that allows users to interactively explore COVID-19 data by selecting specific time frames and regions. Next is to provide clear and insightful visualizations of COVID-19 cases and vaccination rates, enabling better understanding of global and regional trends. The last one is to enhance data accessibility, making it easy for users to track COVID-19 trends and assess the impact of vaccination efforts. Next is about tools and libraries used. The first one, we use pandas to load, clean, and filter COVID-19 data, converting it into a data frame for easy manipulation. Next is the library called matplotlib as PLT. So we use it for creating visualizations for COVID-19 data, specifically plotting graphs to display trends over time, such as new cases, total case, new date, total dates, and vaccination for selected countries. The third library is matplotlib as tickers. So the ticker model provides a function to control the placement and formatting of tick marks on the axis of a plot. Specifically, it's allowed for custom tick formatting, tick placement control. And the last libraries we use is PyCountry. Basically, it provides a list of recognized country names. In this code, PyCountry is used to filter out any unrecognized country names in the dataset to ensure that only valid countries are included in the ranking. Next is the features providing in the program. First of all is new cases. Second of all is total cases. Third is new dates. The fourth one is total dates. The fifth one is new vaccination. And the other half, including total vaccinations, compare new cases, compare total case, compare vaccinations with new cases, and the last one is countries ranking. Let's start with our fifth function we include in the program. So the first one is display. The display function visualizes a selected COVID-19 trends over time for a specific country by creating a line plot. Next is the display comparison. So this function visualizes a comparative trends of COVID-19 data over time between two selected countries, displaying the data as line plots on the same graph. The third one is display compare vaccine cases. So this function creates a side-by-side comparison of new COVID-19 cases and new vaccination over time for a selected countries. The fourth one is specify date. The specify date function filters a data frame based on a specific data range. The function allows you to select data for either a single year or a range of years. And the last function is plot country ranking. This function basically ranks and displays COVID-19 case data for a specific range of countries in a bar graph and plot the data based on the user's input parameters. Next, we're going to talk about input and output. So input provide data ranges based on their chosen mode, which is dragged to guide users through selecting options for COVID-19 data analysis. So here's a description of the input. We have mode selection, country selection, date or year range, and the last one is ranking range for ranking mode. And next is about the output. So the output of this code consists of various interactive plots that display COVID-19 data based on user selections, and the output consists of time series plot, country comparisons, and the last one is ranking bar charts for the ranking mode.
For brief code explanation, the program begins with data loading and filtering. It imports a CSV file containing COVID-19 data and use library named PyCountry. It also extracts date components such as year, month, day for easier time-based analysis. For the function, the code analyzes data and display graph by mode using mentioned libraries. And for interactive user input, we have mode selection, country and date range input for filtering data, custom range input for ranking display, and the program also prevents users from entering incorrect formats or invalid data through multiple validation checks and reprompts. For the output, the code contains time series line plots, comparison plots, and bar charts. This is the main input terminal, where users start by selecting a feature from the list by entering a number. We provide 10 modes for users to choose. For mode 1, new cases, they are prompted to enter the country name with correct capitalization. Then they can choose a specific year or range for analysis, or view all available data from 2020 to the present. For the output, we get a time series plot showing the number of new COVID-19 cases over time for the selected country, in this case the United States. For mode 2, it works similarly but displays cumulative total case instead. For the output of mode 2, it shows the total case of the specific country. For mode 3, it lets user view new COVID-19 days over time. The input interface remains the same, where users specify the country and date range. In this output graph of mode 3, we can observe new COVID-19 days over time. In mode 4, we switch to viewing cumulative total days. Similar to previous modes, the user selects their countries and date range to get a detailed overview of total COVID-19 days over time in that specific location. For the output, it shows the cumulative COVID-19 days total over time. In mode 5, users can view the daily number of new COVID-19 vaccination. Again, they are prompted to enter a country and a specific date range or select all available data. The output shows the new vaccination over time in the specific country.
And next is our sixth mode, which is total vaccinations mode. We select United States, and this time we select to display all the data. As you can see on the graph, the program plots between date and total vaccinations. The next mode is comparing new cases. The input in this mode is quite different from the others, so two countries are required in this case. In the example, we choose the United States and Spain, and we select the data from 2020 to 2022. And the result is the graph displaying both countries' new cases over time in the same graph. So the users can compare the graph of the both countries. As the same as the last mode, we also made a program to compare total cases. We still use the United States and Spain as an example, and we select all the data. The program going to display both countries' total cases in the same graph. And the next is our ninth mode, which is comparing vaccination with new cases. The input only requires one country, which in this case is United States as always, and over the time 2021 to 2023. Both graphs will appear side by side with each other in order to make the users able to compare the total vaccinations and the new cases easily. And our last mode is ranking the countries by total cases. The input only wants the specific time interval and the range of the rank the users want. For example, selecting all interval and ranking the first to the 15th. And the graph will display the ranking of country based on the user's input. In our future, we can working with the user interface to improve our program and make more comprehensive error prevention. And this is our references. Thank you for your attention.